Hello everyone, greetings to all. We are here to present a research paper presentation for the subject software engineering, and the following are the team members. Roll number 17 Aditya Shirke, roll number 25 Sachin Tripathi, and roll number 30 Harsh Waghela. Next slide. Hello everyone. My name is Aditya Shirke, roll number 17, and I am going to present a research paper presentation on the following paper, a progressive software development life cycle, and the author of the paper is Russell Twin. Next slide. So basically talking about the introduction, this paper introduces a new approach to software life cycles called as the progressive software development life cycle. These life cycles basically emphasizes the testing at every phase of the development in order to reduce the cost and the rework and the schedule delays. Basically this paper describes the benefits and requirements of this approach, and it compares it with the other software development paradigms. Next slide. So basically, in this research paper, the author has also talked about the traditional life cycle. So the traditional life cycle is the waterfall model, which the author has taken into consideration. So basically, the waterfall model involves significant effort in analysis, design, implementation before the actual testing part is done. So the software produced is not tested until half of the project has elapsed. So basically, this can lead to significant rework of analysis and design, causing cost overruns and schedule displays. Any analysis or design flow found during the testing causes an unanticipated and unpredictable delay in the development process. So these were basically the bugs which were found by the author in our traditional life cycle, that is the waterfall model. Next slide. So basically, the author has proposed a new life cycle called as the progressive life cycle model. So basically, the progressive software development life cycle is a new approach to software development that emphasizing testing at every phase of the development of the project. This approach involves executing a test of the results of each phase of the development, which reduces the need for significant rework and schedule delays. So basically, when we refer to the following diagram of the progressive lifecycle model, so basically the analysis and design steps are separated from each other, which were indeed combined in the traditional model, that is the waterfall model. So in this, the analysis and design is separated. The analysis model fully describes the application's behavior, including the timings. The design model provides a target code definition, analysis notation, and a suitable to the target environment. So the desired persistence mechanism, if present at that moment, if any, and the performance and the memory requirements of the application are thus applicable to this particular life cycle, that is the progressive life cycle. So basically by doing separation of the analysis and design, this model has came to a progressive life cycle structure. So basically what were the requirements for implementing this progressive life cycle? So it is basically the ability of this model to design system testing and the program for a target platform. The main advantages of this progressive lifecycle model are that it reduces the need for significant rework and schedule delays. This approach is also more efficient and cost effective than the traditional approach, that is the waterfall model or any other traditional models. And this approach is well suited for embedded software development and can be supported by new tooling, which is now possible in these days. Next slide. So basically, the author has also talked about the process maturity. So basically, we know about the capability maturity model, that is the CMM, for the software which is produced by SEI. This has a large and beneficial effect on the practice of software engineering. The criteria and recommendations in CMM concern how engineers go about their jobs and are largely independent of development technology and tools. A large part of the CMM concerns a organization's ability to successfully define, repeat, measure, and optimize the task that uses in building the software. The traditional waterfall lifecycle model makes this difficult because any analysis or design flaw found during the testing causes an unanticipated and unpredictable delay in the development process that is caused. So basically, all these problems are overcome by the progressive lifecycle. Next slide, please. So basically talking about the conclusion, in the new development environments allow for the testing to begin right at the project's inspection. Modern development environments allow for a software development process where testing happens continuously right from the beginning of the project, instead of being just used for documentation, analysis, and design models. These are automatically transformed into working softwares. These advancements fix issues often found in the traditional methods where analysis and design models remain untested until some manually writes the code. The automation which has been possible due to the progressive life cycle enhances the efficiency and productivity of the development process. Also, it increases the collaboration between the developers and the testers. So basically, the author wants to convey a shift from the traditional approach to a modern and a progressive approach through this research paper. Thank you. Now I hand over to my colleague Sachin to continue the presentation.
Thank you, Aditya. Hello, everyone. My name is Sachin Tripathi, row number 25. And the title of my research paper is Life Cycle Based Study Framework of Software Evolution. So the world of software is ever changing. I'm here to discuss a critical aspect of this ever evolving landscape, which is software evolution. Software evolution involves the process of adopting software to meet the new requirement and the changing environment. It is a significant challenge in the software industry. In this presentation, I will introduce you to the research framework, which aims to decrease the complexities of the software evolution. So in this paper, author has divided the methodology into 4 parts. The first part is handling requirement changes. So we use a technique called scenario modeling to capture and understand these changes effectively. The second is smooth mapping to object design. Here, we achieve this by leveraging the concept of isomorphism, which allows us to maintain the consistency between requirement changes and the software design. Third one is retrieval search reasoning of requirement changes. So we use a tool called scenario ontology description language, which enable us to retrieve search and reasoning requirement changes. The fourth one is development of supporting tool. So the tool are invaluable and maintaining the improving software even for the older legacy system. Now this is the process example of change transmission, which consists of total 5 parts. The first part is scenario layer. Scenario layer, it includes various scenarios that capture the user requirement, which is the bottommost layer. The second layer is user case layer. It contains use cases that encapsulate the related scenario, showing the connection between scenarios and functionalities aspect of software. The third one is object layer. So this object are responsible for implementing use case and carry out specific task. The fourth one is component layer. So in this layer, components are the group of work together to fulfill the broader functionality requirement. And the last layer, which is the topmost layer, is the software architecture, which is the which layer symbolizes the overall structure of the software system. Now, this is the transmission of tracing process, which consists of total 3 layers. The first layer is software lifecycle layer, and it is represented by the blue ellipse. And here it contains three models. The first one is requirement model, then system, and then software architecture model. The second layer is transmission layer, which illustrate which entities are influenced by the change in software requirement. The third layer is method layer of tracing change, which specify how changes is stress. So, in conclusion, the software evolution is a critical as a software need to continuously adopt the changing environment and requirement. This research paper framework offers a structured approach to address the complexities of software evolution. Now, I would like to hand over to Harsh Waghela.
Thank you, Sachin. My name is Harsh Wagela, role number 30, and I will be presenting you on the topic aspects of improvement of software development lifecycle management. Next, next. So, as we know, safety critical software development demands high quality standards and compliance with industry specific directive. So, software development lifecycle management system elevates documentation burdens commonly used in plan driven development. The choice of the right SDLM system is crucial as it should align with the team's specific needs, support traceability, and code reuse. So, this paper objective is to address SDLM system selection process, selection questions which will provide a case study and create a system that meets both developer as well as manager needs while enabling traceability and code reuse. Next. So when talking about environment of application, the requirement scopes are the requirement collection is only for medium size enterprise. Special emphasis is given on medical device deployment and applicability extends beyond medical devices to benefit any safety critical software development team. And while talking about existing SDLM system, the company currently uses an SDLM system with prior experience. The requirement encompass the entire system, entire software development lifecycle, and they also pertain to the application environment and possible future extension. Next. So, so here are the practices which we can do to improve the SDLC. The first one is workflow management. Uh, the main reason is the poor work management is one of the reasons that SDLC does not improve productivity and performance. Inefficient task allocation, lack of work progress, and improper planning disturbs the development workflow. The second one is clear scope of work. SDLC begins with ideation and studying requirements, and ambiguous scope of work will negatively impact developer productivity. So we should include deliverables, timeline, milestones, report, etc. The third one is documentation. Documentation is just making a written record of project related details, including deliverables, deadlines, resources, and other, with the motive to unify and organize project information. It is vital for engineering teams that as it keeps team aligned, eliminates the chances of scope creeps, and lessen irritation sounds rounds. The next one is Scrum best practices. Most of the development team works under Scrum arrangement. The engineering management should opt for best Scrum practices such as asynchronous communication and data-driven workflow. And when talking about integration, we should opt for CI/CD, which is continuous integration and continuous development to avoid last-minute hassles of integration. It saves time by reducing the chance of lost code contents. And we should also track engineering metrics. Looking at engineering team performance is vital for seamless SDLC. The manager should track metrics such as cycle time, DORA metrics, and code review metrics to improve development velocity and eliminate bottlenecks. Uh, we also need collaborative learning, collaborative training using the uh, buddy system in an effective way to train developers. This leads to better team relations and communication. In this system, two members train and work in pair. The process is faster and more efficient as it enhances productivity and increases job satisfaction. We can track the progress using data and manage it accordingly. The next one is breaking down the task. Conduct sprints review and in development workflow health check to break task into smaller milestones. This helps the manager with better engineering team management. It leads to faster code review, better cycle time, and improve PR metrics. And the last one is data driven success, which is settling the right SDLC requires looking into engineering engineering team metrics and data to get actionable insight. It helps in finding loopholes and enhancing the cycle with right metrics. So doing the sprint review, looking for bottlenecks and identifying DevOps blocker and planning workflow accordingly. Plan sprints by referring back to sprints, and uh, re- retrospective and logs review. Next. So just to conclude, safety critical software development heavy documentation need require a robust software development management team. Introducing or changing SDLM system involves considering various aspects, identifying disadvantages, help plan to overcome deficiency when adopting a new system. So initially requirements may be informal and subjective. The next step is to establish objective measure based on this requirement. So it's essential to clarify reasons for rejecting certain aspects. And moreover, the process includes a case study to analyze emerging SDLM system. Thank you.